All right, number 12 looks a little bit different, but upon close examination, you can see that it's similar to something we've done before, and we have to just do a little, manipulation with math to solve this one. So, as you look at this problem, we have a log base 3 of x, and the whole thing is squared. Normally, we just see the squared on the variable, not the whole expression. So this is a little bit different. This is not the same thing that we're used to looking at, log base 3 of x, the whole thing inside parentheses squared. This is different. What we want you to see or get is that this is similar to a quadratic expression. We have log base 3 of x for both our log expressions. So we're going to let that equal something. We're going to say log base 3 of x. We're going to let that equal y. We're going to use a substitution method. So this whole thing equals y. So as I'm looking at this expression, this is log base 3 of x whole thing squared minus 3 log base 3 of x equals 18. All right, so as I replace log base 3 with y, this is a y, so it's y squared minus 3, this is a y, so 3y equals 18. So from here, it looks like a quadratic equation. We're going to solve that. So move the 18 over. We have y squared minus 3y minus 18 equals 0. All right, and then we're going to try to factor this. So factors of 18, 1 and 18, 2 and 9, 3 and 6, and I think this is what we need. 3 times 6 will give us 18, and if you subtract those, we can get 3. So we're going to separate this as y and y, and then 3 and 6. First sign is the larger number. Second sign tells me they're different. All right, so these are my two expressions. Once we get the y's isolated, we can now replace them, okay, with our log expressions. Okay, so this is now log base 3 of x plus 3. Okay, this is that factor, and this is now log base 3 of x minus 6 is that factor. Okay, we will still set both factors equal to 0, and then we'll be able to solve two separate log expressions and get two different answers. And then we got to check to see which one works. So setting this equal to 0, we have log base 3 of x plus 3 equals 0. And then over here we would have log base 3 of x minus 6 equals 0. All right, we will move the 3 over. Okay, so we have log base 3 of x equals negative 3. Over here we would move the 6 over, so we have log base 3 of x equals positive 6. And then from here we will write them both in exponential form. 3 to the negative third power is x. So x equals 3 to the negative third power, which will give us x equals 1 over 3 to the third, and that equals 1 over 27. So that's one possible answer. Over here, 3 to the 6, x equals 3 to the 6th power, and that will give us 981 times 9, is it 729? Let's see. 3 raised to the 6. Is it 729? Okay. So this will give us 729. Okay. From here, we just need to check. If I plugged in 1 over 27 to the original up here, this log of x, that would still be a positive. That would still be positive, so we're good. And then also if we plug in 729. So in this case, both answers work, 1 over 27 and the 729.